Okay, so I've got a little bit of an Easter puzzle for you to try and solve. So I'm going to solve these challenges to make sure you feed the nation. The nation needs feeding. So, freight is very important in transporting food, consumer goods and other vital medical supplies around the country. These are the standard figures on a normal working week. So 72 freight trains in and out of Felixstowe every week, 20 freight trains in and out from London Gateway in Essex, carrying up to 500,000 tonnes of products, including food, drinks, consumer goods and vital medical supplies. These figures might be different right now. I'm guessing we'll vamp up efforts to transport medical supplies and other important goods around the country. The network of freight trains across the globe. The transportation of food is a quick and seamless one normally. Fresh fruit and vegetables can enter the UK from Italy within 12 hours of being harvested. Delicious wines from France can reach London in as little as 60 minutes. And there's refrigerated carriages to make sure it's all kept cool. So, I'm going to challenge you to try and solve this little Easter puzzle. So first off, we've got a location here. I want you to try and work out where it is. Your first clue is it's somewhere between the M1, A5 and A428 roads. This station connects to the West Coast Main Line. The original development was built in the 1990s and was about 300 acres in size. The acronym for this location is DIRFT. See if you can crack it. Here's a visual clue which might help you a bit, to give you the D anyway. So what could it be? It's Daventry. So Dave Lister, and Tree, Daventry. So Daventry International Rail Freight Terminal. It's collecting goods from around the Midlands. The train runs from the Stortford depot at Daventry International Rail Freight Terminal near Rugby to Grangemouth Rail Terminal in Scotland. So it's shipping the equivalent of 26 lorries daily in each direction. 90% is filled up by Tesco and 10% by Coca-Cola. So I want to challenge you to calculate the amount of carbon dioxide 26 lorries produce daily. To calculate this, we are going to be timesing distance, the distance travelled by your lorry, the weight of the lorry, and a specific emissions factor is going to be put into the equation as well, and you'll be timesing all of those together to calculate it. Our lorry is 20 metric tonnes in weight, and we're going to look at the journey from Daventry to Grangemouth. It's 341 miles one way, so that's a one-way journey. So if you use this link, you'll be able to find out a bit more information that might help you to solve this on your own, work through it. So first of our distance, we're going to make it a round trip, so we times it by 2. So 361 miles times by 2 gives you 722 miles for a round journey of one lorry. We then convert that into a tonne-mile figure by timesing it by the weight of the lorry, and that gives us 14,440 tonne miles. EF figure of 161.8 grams is the amount of CO2 that's given out per tonne per mile that the lorry is travelling. And we've got 14,440 tonne miles because we times our miles and our weight in tonnes together. So then we have to times that by this figure here to give us the amount of grams in total the lorry will be emitting. And there's the calculation there. For one lorry doing a round journey, 26 lorries, so times it by 26, 26 lorries doing a round journey, and then divide it by 1,000,000 to convert it into metric tonnes of CO2. We did make some assumptions when doing this. Can you think what they might be? We made the assumption over the weight of the shipment and Also, the EF number is based on one that's in ton miles, not so short ton miles in America, not ton miles. So you could calculate it for that as well and make it more accurate. That's something you could have a go at. Looking at carbon dioxide emissions, these are figures in million metric tons per year for the UK. So our example reduces CO2 by 60.58 metric tons per day, which is about 22,110 metric tons per year. So the more freight trains we use instead of lorries, the less CO2 is going to be emitted. It is estimated that rail freight service will replace about 130,000 lorry journeys and save 3 million road miles a year. You could look at trying to work out what that equates to in carbon dioxide emissions, but it will definitely help to lower them and hopefully lower the impact of global warming. Well done for solving the first challenge and getting the train moving. You've now left Daventry and you're well on your way. Unfortunately, you've been delayed because signalling equipment has been stolen. What chemical is used in the cables, electrical cables, to allow them to conduct electricity? So think of that one. Let's try and solve this next challenge. So copper is used in electric cables. Why can copper and other metals conduct electricity? So copper can conduct electricity because it has these free electrons. Sometimes they're referred to as delocalized as well. So you've got the copper ions, positive copper ions, and the electrons are free moving. And there's very little resistance in copper, and that's what makes it a really good conductor. In fact, only silver is a better metal, is a better conductor than copper. Cable theft is responsible for a lot of delays on the rail network. Here's a graph just trying to illustrate the impact of that. So these are minutes down here, so 60,000 there, 50,000, 40,000, 30,000, 20,000, 10,000. And these are the years 2014 to 15, 15 16, 16 17, 17 to 18, 18 to 19. So you can see that it does cause a lot of delays. Delaying people's journeys, stopping things from being moved around that need to be moved around. The reason why it's done is because copper is valuable. As you can see here, copper wire fetches currently £4.60 per kilo. And this has led to organisations such as Network Rail pressuring the government, lobbying the government for them to put in something to stop people stealing stuff and then selling it on as scrap. And ended up with the Scrap Metal Dealers Act in 2013. And this means people have to be licensed to sell scrap metal. And hopefully the idea was it would cause less wire to be stolen. However, you can see here there are still quite a lot of delays attributable to cable theft on the network. So you've proven you've got good knowledge of metallic bonds and know about metals conducting electricity. The next challenge is to work out where those cables were stolen from. So the copper wires were stolen from the busiest station in northern England. It connects to the East Coast Main Line, on which London North Eastern Railway provides high-speed intercity services to London's King's Cross every half hour from this station. And the police want to know if you've got any leads. And this is a bit of a visual clue, and another one if you know what it looks like. What do you reckon? So, the copper wire was stolen from a station near Leeds. Now you've got a decision to make. Are you going to continue as planned? Your train's been planned safely, it's got margins put in place that will allow it to run safely. Or are you going to reroute this train? Are you going to try and avoid those delays that are in and around Leeds and get your freight cargo transported to where it needs to be for the Easter weekend? If you go for option one, you could lead to more delays, which in their very essence are not very safe, because someone's had to take control and stop that train from conflicting with another one, from not following the train planning rules, which means that it's not going to be a safe enough distance from another train. Your train being delayed might mean that your food's not delivered in time to be redistributed to supermarkets. It can lead to costing the freight company money. Delay attribution costs money. Money moves hands in delay attribution. It's a bit of a blame game. And it might result in a lack of food on the shelves for the Easter weekend. Option 2, it might sound like a risky strategy rerouting the train, because then it might end up clashing with other trains that have been planned to use that area. However, control might be able to find a safe and compliant route for the train to follow, and it might result in there being less delays and the train getting to where it needs to be in time to distribute its supplies around the country. So you go with option 2, your train's on its way, it's been rerouted. It's using the west coast line instead of the east coast line, it's following a different passage. However, your next challenge is looking at landslips and what we can do to try and avoid these. Sometimes they do happen. A train follows a set route, it can't swerve around a pile of rocks in its way. Or when there's a pile of debris on a track, trains will need to be rerouted, and this might cause delays. It's a bit of a STEM challenge. I want you to design and engineer a solution to stop landslips. So what causes a landslip? You've heard of weathering, the wearing away of rocks, and erosion, once they've been worn down, it's the movement of those rocks. It's different types of weathering: biological, chemical and physical. Other factors to be considered that might cause a landslip are the angle of the slope. The steeper the angle of the slope, the greater the forces acting on it, and therefore the increased chance of a landslip. Type of rock, different rocks will be of different strength, and therefore some can be weathered quicker than others. Extreme weather, if there's a period of high rainfall, this can lead to increased weathering and then erosion of the rock and increases the chance of landslip. Tectonic activity as well could play a factor, although not really a major one in the UK. How do we stop landslides? Firstly, the key thing is to identify areas that are prone to landslides, and Network Rail do this with helicopters that are equipped with laser imaging detection. And they can find out where areas are that are more prone to landslides, identify them, and then we can take action. They use motion sensors and CCTV to detect soil and rock movement. These sensors will then send an alarm to the signaller, who will stop the train if alerted and wait until the area has been inspected by engineers. So it's making sure it's safe. They can also stabilise the slope by putting drainage or steel rods or soil nails into the slope to try and make it more stable, or to drain the water away that causes the erosion. If these options are not sufficient, we will then reprofile the slope to reduce its angle, so making it a more shallow angle as opposed to steep, and then reducing the likelihood of it slipping. And you can see here that netting has been put over the slope to try and hold it in place and stop the landslip from occurring. Your freight train's been going now for about 8 hours, and it is near the location from the previous picture, which is, can you guess it from the visual clue? From the previous picture, which had the netting over it to stop landslips from taking place, is called Lamb Hill. And you're near quite a big station in Scotland there. Can you guess what that is from the clues and the visual? So the clues are that it's one of only 20 stations managed by Network Rail on the network. It was opened by Caledonian Railway on the 1st of August 1879, and it's on the West Coast Main Line. Can you guess it from the visual clue as well?